Hello, everyone, and welcome to HNM Technologies online training program. In this session, we are going to understand data preprocessing and feature engineering. Before building any machine learning model, we must understand that real-world data is rarely perfect. Data may contain missing values, duplicate records, errors, or inconsistent formats. If we train a model using poor quality data, the model's predictions will also be poor. That is why data preprocessing is one of the most important steps in machine learning. In fact, data preparation can take up to 70% of the total project effort. In machine learning, data can exist in different formats. Numerical data includes numbers such as age, salary, or marks. Categorical data represents categories such as gender or city. Text data includes reviews, messages, or comments. Date and time data includes timestamps or schedules. Understanding data types is important because different pre-processing techniques are applied to each type. Missing values are very common in real-world data sets. There are multiple ways to handle missing data. One method is removing rows that contain missing values. Another method is replacing missing numerical values with the mean or median. For categorical data, we can replace missing values with the most frequent category. Choosing the correct strategy depends on the dataset and business requirement. Machine learning models work with numbers, not text. Therefore, categorical data must be converted into numeric format. Label encoding assigns a number to each category. One hot encoding creates separate binary columns for each category. For example, if we have cities like Hyderabad, Chennai, and Mumbai, each city becomes a separate column. Encoding helps models interpret categorical data correctly. In datasets, some features may have very large values while others are small. For example, salary may range from thousands to lakhs, while age ranges between 18 and 60. If we do not scale features, the model may give more importance to larger numbers. Feature scaling ensures that all variables are on a similar scale. Common methods include normalization and standardization. This improves model performance and training speed. Feature engineering is the process of creating new features from existing data. For example, instead of using date of birth directly, we can calculate age. We can also combine features, such as calculating total marks from individual subject scores. Feature selection helps remove irrelevant features that may confuse the model. Good feature engineering can significantly improve model accuracy. After preprocessing, we divide the dataset into two parts. The training dataset is used to train the model. The testing dataset is used to evaluate the model's performance. A common split ratio is 80% training and 20% testing. This ensures that the model performs well on unseen data and avoids overfitting. Let us summarize the data preprocessing workflow. First, collect the dataset. Second, clean the data by handling missing values and duplicates. Third, encode categorical variables. Fourth, scale numerical features. Finally, split the dataset into training and testing sets. Once these steps are complete, the dataset is ready for model training. Consider a real-world example of predicting student performance. First, we collect student data such as marks, attendance, and demographic details. Next, we clean the data and handle missing values. Then, we encode categorical variables like gender. After scaling numerical values, we train a model to predict whether a student will pass or fail. This demonstrates the importance of proper data preprocessing. In this session, we learned that data preprocessing is a crucial step in machine learning. We discussed handling missing values, encoding categorical data, feature scaling, and feature engineering. Without proper pre-processing, even the best algorithms will fail. In the next session, we will explore supervised learning algorithms in detail. Thank you for attending this session.